Dear students, welcome to this lecture series of turbo machine subject for TE Mechanical. We are discussing unit number 1, Introduction to TMC, turbo machines and impact of jet. In this, let us start with our lecture number 2 after discussing the syllabus in lecture number 1. In this lecture number 2, we will cover definition, classification and comparison points of turbo machine devices, TMCs. So let us begin with definitions. First definition is of a fluid machine. What is a fluid machine? A fluid machine is a device which converts the energy stored by a fluid into mechanical energy, or vice versa, or it converts the energy which is in the form of a mechanical energy into a energy of a fluid. So a fluid machine is a device which converts one form of energy into another form of energy. It converts fluid energy into mechanical energy or mechanical energy into fluid energy. Now the energy stored by a fluid mass appears in the form of potential, kinetic and intermolecular energy. Okay. Fluid mass has three forms of energies: potential energy, kinetic energy, very well known to you, and also intermolecular energy, which can be called as simply internal energy. While the mechanical energy, on the other hand, is usually transmitted by a rotating shaft of a fluid machine. So machines using liquid, that too mainly water, for almost all practical purposes are termed as hydraulic machines. The fluid machines using liquid and that too water are called as hydraulic machines. So this is regarding definition of a fluid machines. Next is classifications of fluid machines. First criteria, a classification based on direction of energy conversion. Okay, the device in which the energy held by the fluid is converted in the form of mechanical energy of a rotating member is known as a turbine. So this is classification based on direction of energy conversion. So the device where the fluid energy is converted into the mechanical energy of a rotating member is known as a turbine. While the machines, on the other hand, where the mechanical energy from the moving parts of a machine is transferred to a fluid to increase its stored energy, the stored energy of a fluid by increasing either its pressure or velocity, are known as pumps, compressors, fans and blowers. So in these devices, the energy from the moving parts is transferred to the fluid, okay, being handled by that machine, respective machine, so as to increase its stored energy. It means it increases its pressure and or velocity. So this is classification based on direction of energy conversion. Next criteria is classification based on principle of operation. So the machines whose functioning depend essentially on the change of volume of a certain amount of fluid within the machine are known as positive displacement machines. This is a classification based on a working principle of a machine. So the class of machines where their functioning is dependent on the change of volume of a certain amount of fluid inside the machine are known as positive displacement machines. Okay. The word positive displacement comes from the fact that there is a physical displacement of the boundary of a certain fluid mass as a closed system. There is a physical displacement of a boundary of a fluid mass which acts as a closed system. Examples are reciprocating engine, reciprocating pump, or reciprocating compressor. These are all examples of positive displacement machines. Positive displacement machines means what? There is a physical displacement of the boundary of a fluid mass which acts inside the machine as a closed system. Okay. The machines functioning the functioning of which depend basically on the principle of fluid dynamics are known as turbo machines or rotodynamic machines. Okay, this is classification based on principle of working. A machine functioning which depends basically on the principle of fluid dynamics are known as turbo machines or rotodynamic machines. They are distinguished from positive displacement machines in requiring relative motion between the fluid and the moving part of the machine. Okay, so in a turbo machines, what difference we see? There is a relative motion between the fluid and the moving part of the machine, unlike positive displacement machines. Also, the rotating element of the turbo machine or rotodynamic machine usually consists of a number of vanes or blades, and it is known as rotor or impeller, while the fixed part is known as stator. The rotating element of a turbo machine device usually has a blades or vanes, and that rotating member is known as a rotor or a impeller, while the fixed part in the machine is called as stator. Remember, impeller is the heart of turbo machine within which change of angular momentum of the fluid takes place, imparting torque to the rotating member. So for the time being, you should remember, inside the impeller of a turbo machine, the change of angular momentum of the fluid takes place, and that results in a torque acting on the rotating member. For example, for turbines, the work is done by the fluid on the rotor, while in case of pump, in case of compressor, fan or blower, the work is done by the rotor on the fluid element. This is very logical. Okay. Third criteria is based on classification based on direction of fluid in the rotor. Direction of fluid flow in the rotor. So in radial flow machine, the main direction of flow in the rotor is radial. The first type is radial flow machine. The flow direction in the rotor is radial, while in axial flow machine it is axial. Here you can see the schematic of different types of impellers. This first one, A, radial flow machine. So the flow of fluid in an impeller is purely radial along the radius like this, from inner periphery to outer periphery, and this is the axis of the impeller, this one, horizontal axis. the flow of fluid is purely radial. So this machine is called radial flow machine. In axial flow machine, the flow of the fluid is purely axial, parallel to the axis. So this is called axial flow impeller. And there is one more. If the flow is partly radial and partly axial, the term mixed flow machine is used. So there is a partly axial and partly radial flow. So this one is called as mixed flow machine or mixed flow impeller. Examples of radial flow machines are Francis turbines and the centrifugal pumps and centrifugal compressors as a radial flow machines. The examples of axial flow machines are Kaplan turbines and axial flow compressors. Fourth bit, classification based on fluid used. The fluid machines are use either liquids. Now as we say the machines are fluid machines, it means some fluid flows through that machine. Okay, so they use either liquid or gas as the working fluid depending upon the purpose of the machine. The machine transferring mechanical energy of rotor to the energy of fluid is termed as a pump when it uses liquid. Okay, the machine transferring mechanical energy of a rotor to the energy of a fluid, and if the fluid is a liquid, then the machine is called as a pump, and it is termed as compressor, fan or blower if the fluid is gas, if it is handling a gas. Okay, the compressor is a machine where the main objective is to increase the static pressure of a gas, while fans or blowers mainly cause a high flow of a gas. It means fans and blowers increase mostly the kinetic energy of the fluid. Okay, where the change in static pressure is quite small. This is very important concept. Okay, this is the classification based on the fluid used. The fluid can be either liquid or it can be either a gas. If the machine is using a liquid and if it is converting mechanical energy into the fluid energy, then we call it as a pump machine. If it is handling a gas and if it is converting mechanical energy into a fluid energy, then there can be a compressor, fan or a blower. But again there is a difference between compressor and fans and blowers. In a compressor machine, what happens is the objective is to increase the static pressure of a gas, while in case of blowers and fans, the objective is to get high kinetic energies, so to have high flow of gas, where in these devices change in static pressure is quite negligible. If the liquid used by the turbines producing power is the water, then they are termed as water turbines or hydraulic turbines. And the turbines handling gases in practical fields are usually referred to as a steam turbine, a gas turbine and air turbine if they use steam, gas or air as the working fluid. Here by gas we mean a mixture of air and products of burnt fuel in the air. Now coming to our important class of machines that our subject deals with, that is turbo rotodynamic machines. Remember, turbo machines are also known as rotodynamic machines. Why? Because the working of a turbo machine, which is a type of a fluid machine, the working is based on the principle of fluid dynamics. That's why these are called as rotodynamic machines. Why roto word? Rotor word because there is a important element called as a rotor, which is a part of a machine. So this is first point. The important element of a turbo machine in general is a rotor consisting of a number of vanes or blades. So in all turbo machines we have a common element that is known as a rotor, and which has a number of vanes or blades provided on its periphery. That's why it is called as roto machine, rotodynamic. There always exists a relative motion between the rotor vanes and the fluid passing through the turbo machine. Remember this. The fluid has a component of velocity, and hence it also has a component of momentum in a direction tangential to the rotor. While flowing through the rotor, what happens? The tangential velocity of the fluid and hence the momentum of the fluid changes. The fluid has a velocity component and a momentum component in a direction tangential to the rotor, and as the fluid flows through the rotor, the tangential velocity changes. So thus the momentum along the tangential direction changes. The rate at which this tangential momentum changes corresponds to a tangential force on the rotor. This we will understand better once we start with our derivations. Okay. In a turbine, the tangential momentum of the fluid is reduced, and therefore work is done by the fluid to the moving rotor. But in case of pumps and compressors, there is an increase in the tangential momentum of the fluid, and therefore work is absorbed by the fluid from the moving rotor. This you will understand when we cover the derivation part. Okay. Now these are some photographs of actual turbo machines, as you see here. This is the impeller of a radial flow fan. So rotor of a radial flow fan. You can see the actual pictures and the actual dimensions. Next is, this is the centrifugal compressor rotor, right? Centrifugal compressor rotor, and this is a large rotor, large impeller, and this one is a small impeller provided on one common shaft. This is an impeller of a centrifugal pump. Okay, and it is open type of impeller of a centrifugal pump. So there are types of impellers. This one is a multi-stage axial flow compressor rotor. Multi-stage. So there are multiple rotor blades. Here you can see of a axial flow compressor rotor. And lastly, this is the axial flow pump rotor, where the flow of a fluid is axial through this axial flow pump. Okay, thank you.